Hi my dear students. So today we are going to discuss about the projectile motion. So that's one of an example for the motion in a plane. So those who are very familiar with or those who are interested in the sports may know about the javelin throw as well the disc throw and all the categories of the sports side. So in that javelin throw, you know that the path with which the javelin is moving is like a projectile. Okay. So we are just throwing the javelin or the disc. It will follow a path almost like this. So such movements, if you are throwing a ball, a cricket ball, likewise the movement of that or the path which is followed by that particular body, actually there is a projectile path, and that movement of that particular body will be known as the projectile motion. So in detail we will study. So the maximum height, how much a projectile body can move, and how much will be the time required to reach the horizontal surface or the land. For the landing, how much time it is required, and as well what will be the horizontal range. All those things we are going to discuss today. Actually, with the help of that kinematic equations, we are going to derive all those things, these values. Okay. So first of all, consider this is the initial point from which we are throwing the particular body. We are just throwing the body. So this is the initial point where the x0 and y0 are the coordinates, x and y coordinates at the initial point. x0 for the x value at the initial point and y0 the y value at the initial point. Both are taken as 0, 0. That is the origin, 0, 0. Now this is the path of the projectile, and v0 is the velocity, initial velocity. You are just throwing a particular body with an initial velocity of v0, and the initial velocity, that means the point, the initial point, the path, the tangent to that path, okay, at the initial point, which is making an angle theta 0 with the horizontal surface. Okay. So theta 0 is the angle between the tangent to the path and at the initial point and the horizontal surface. That is the theta 0. So you know that here the v0 can be formed into or divided into two components, that is one on the x-axis and another one is on the y-axis. For the initial component of the v0, that means for the initial velocity v0, there will be two components. One is on the x-axis, that is v0 cos theta 0, and on y-axis that will be v0 sin theta 0. Okay. So the velocity, the initial velocities components on x-axis and y-axis are v0 cos theta 0 and v0 sin theta 0 respectively, that we have discussed already in the vector components. The component of vectors we have discussed that one, the parallelogram law and all. So v0, the vector v0 can be taken as v0 cos theta 0 I cap plus v0 sin theta 0 j cap. Okay. And where theta 0 is the angle between the tangent to the initial path of the particular body with the horizontal surface. And now let us come to the acceleration values. The acceleration will also be having two components. One is on the x-axis, x direction, horizontal direction, and one will be on the vertical direction. Here on the vertical direction, the acceleration value will be that is the acceleration due to gravity, and that will be minus g. And on the horizontal there will be no acceleration. Okay, there will be no acceleration on the horizontal, or the horizontal component of the acceleration will be considered as 0. Ax will be 0 and ay will be minus g. Minus g is the acceleration due to gravity, and which will be acting downwards always. So the magnitude will be taken as minus g. The minus sign, the reason for the minus sign, that is the acceleration due to gravity will be always acting downwards. Okay. And then in the form of vector, the vector A will be, the horizontal component is 0 only the vertical component will be there, that is minus g j cap. J cap means in the y direction. Minus y cap is minus y direction. Minus j cap is minus y direction. Okay, that are the major things regarding the acceleration, the components of the initial velocity and the component of the acceleration. So remember that horizontal, the acceleration, the component of the acceleration on the horizontal, or the horizontal component of the acceleration will be 0 in the projectile motion, and the vertical component will be always minus g. A will be is equal to a, y will be is equal to minus g, and in vector form, vector a will be is equal to, in total vector, the acceleration vector will be is equal to minus g into j cap. And as well the initial velocities components, initial velocity v0 and that making an angle theta 0 with the horizontal plane or the horizontal surface. Then the horizontal component will be v0 cos theta 0 and v0 sin theta 0 will be the vertical component. That means upward the initial velocity will be v0 sin theta 0, and towards the right side the velocity will be v0 cos theta 0. Totally, if you are taking the entire velocity, that means v0, the direction of v0 will be the tangent, will be in the direction of the tangent for that particular point. Okay, so v0, the initial velocity in the x direction v0 x, that will be v0 cos theta 0, and the initial velocity in the direction of y will be v0 sin theta 0. The x and y components of the initial velocity v0 x and v0 y. Here v0 x is the initial velocity in x direction and v0 y is the initial velocity in y direction. Okay. Now let us come to the displacement. You know that the displacement equation x will be is equal to v0 t plus half a t square. That is the equation for, or the kinematic equation for the displacement. So here in the first case, so two components will be there for the displacement also. One will be in the x direction and another will be in the y direction. First we are going to consider the x direction. In the x direction, whatever the value of the displacement is happening. So x will be v0 x into t, that is the v0 t plus half a t square, but the a value, x value is 0, so half a t square, half ax into t square will be 0. Okay. So the displacement after a time t, where the time it is t, okay, after a time t, if you are going to find out the displacement, then the displacement occurred in the x direction will be v0 x into t, and the another time, that the plus half a t square, where the a value if it is 0, hence we don't want to consider that one. So v0 x is actually, that is the initial velocity component of the x direction or on the x axis. That is actually v0 cos theta 0. So v0 x is v0 cos theta 0 into t. That is the displacement occurred for a particular time t in the x direction. Now let us come to the displacement occurred in the y direction. There also v0 t plus half a t square, where v0 is equal to, that means v0 y we have to consider in the y direction. So that will be is equal to v0 sin theta 0 into t, v0 t ho gaya, minus y minus, actually the g value, acceleration value ay is minus g. So plus half a t square will become minus half into g into t square. Okay. So the x and y components of the displacement for a particular after a time t. So x will be v0 x into t, that is v0 cos theta 0 into t, and here y will be is equal to v0 y into t, that is v0 sin theta 0 into t, minus half a t square instead of half a t square, where a is equal to minus g, so substituting the value minus g as a, then minus half g into t square. Okay. So these are the displacement after a particular time in the displacement components of displacement in x direction and in y direction, how much displacement is happened. Okay. Now let us come to the velocity after a particular time. Actually, you know that v is equal to v0 plus half at. That equation we can use here, x direction and as well y direction. The velocity, the particular value of the velocity after a time t. So in x direction, the Vx will be is equal to V0 cos theta 0 plus Ax into t. But where the Ax value it is 0 only, that is the acceleration in the horizontal component of acceleration is equal to 0. So Ax will become 0. So we don't want to consider that Ax term over here. So the remaining will be Vx is equal to V0 cos theta 0, where V0 cos theta 0 is actually the initial component of the velocity. So the x component, for any time you are considering the x component of the velocity, the x component of the velocity will be always equal to the initial velocity. Initial velocity, that means initial s component's velocity. That is Vx will be is equal to V0 cos theta 0, that is equal to V0 x. For any time interval, if you are considering the Vx value, that will be equal to, that is horizontal component of the velocity, that will be always equal to the initial horizontal component of the velocity, that is V0 cos theta 0. Vx is equal to V0 cos theta 0. And now the the vertical component at a particular time t, the velocity Vy will be is equal to V0 sin theta 0. That is the V0 sin theta 0 is the initial vertical component of the velocity minus g into t. V equal to V0 plus at. Okay. Vy is equal to V0 sin theta 0 plus gt. This is the velocity at a particular time t. This is the initial velocity, acceleration into t. Just simply we are just substituting our values into the kinematic equations that we have already derived. Okay. So these are the major portions, that means the velocity components, initial velocity components and the displacement components and the velocity components for a particular time t. So this much things you have, this much things are clear. Now here the Ax value, the horizontal component of the acceleration is equal to 0 even if the vertical component is minus g. That means we can say the horizontal and the vertical components are independent, they are not depending each other. Actually it was already stated by the Galileo in 1632 one of the book, that is Dialogue on the Great World Systems. Okay. So we can say the horizontal and vertical components are independent. Now we will discuss about the path of the projectile. Okay, the path of the projectile. Okay, now let us come to the equation of path of the projectile. So we have seen that the displacement in the x direction is equal to V0 cos theta 0 into t. So from that one we can write the t is equal to x divided by V0 cos theta 0. We are just taking this V0 cos theta 0 to the numerator of left hand side. So t will be is equal to x by V0 cos theta 0, or x by v cos theta 0 is equal to t. And y value, the displacement occurred for a particular time t, that means in the y direction, in the vertical direction, y will be is equal to V0 sin theta 0 into t minus half into g into t square. Now we are going to substitute the t value, the t is equal to x by V0 cos theta 0 into, or in the places of t in the form of or in the equation of the y. Okay. So we are just substituting the t, that is x by V0 cos theta 0 over here in the equation for the displacement component in the y direction. So this equation will change as V0 sin theta 0 instead of t, x divided by V0 cos theta 0 minus 1 by 2 into g, minus 1 by 2 into g, that is g by 2, t square, that is x by v, x by V0 cos theta 0 all square. Okay. So x divided by v0 cos theta 0 all square, that is t square. Now you can see that v0 sin theta 0 divided by v0 cos theta 0. V0 will be cancel each other. Sin theta 0 by cos theta 0 will be tan theta 0 into x minus g divided by 2 into v0 square cos square theta 0 square. That means cos square theta 0. That is v0 cos theta the whole square. You can write like that. v0 cos theta 0 the whole square into x square. Now we have to compare this equation with ax plus bx square, where a will be tan theta 0 and g divided by 2 v0 cos theta 0 all square, okay, into x square will be there. So this one will be your b. So a and b are constant. So ax, the minus g you can take, okay, minus g, let us consider that one as the constant. So plus x square plus b into x square. So it is in the form of ax plus bx square, okay, where b is equal to minus g divided by 2 v0 cos theta 0 all square and a is equal to tan theta 0. So actually this ax plus bx square, if an equation is in that form, that is actually the equation for a parabola. So we can say the path of a projectile motion is parabolic. The path it is actually parabolic, and this will be the equation of path of a projectile motion. That is y is equal to tan theta 0 x plus minus g divided by 2 into v0 cos theta 0 the whole square into x square. Okay.